Hello dear student, welcome to my YouTube channel. In this video we will see isomerism and that it has been classified into two classes, that is structural isomers and stereoisomers. So on the right hand side you can see the picture. Actually the molecule, it is been represented on the paper in the form of an 2D structures, but molecule in actual it is an 3D structure. You can say this is a 3D structure which has been connected to the carbon atom, and this is an actual structure and it can be represented with the help of some stereochemical structures, but we will see only what is an isomerism in this part. So isomers are what? Isomerism, it is a phenomenon of exhibiting two or more compounds with the same molecular formula but different physical and chemical properties. So they may have different physical and chemical properties but same molecular formula. It can be classified into two classes, structural isomers and stereoisomers. Now we will see what is actually it means. See this for an example. In this case, example, it is often like the structure of an ethanol and structure of an dimethyl ether. Number of carbons are same, that is carbon 2, hydrogens they are 6 and oxygen is 1. Here also number of carbon they are 2, number of hydrogen is 6 and oxygen is 1. Now you can see that a molecular formula is same but different in physical and chemical properties. So different in physical and chemical properties in the sense of what? It may have different melting point, it may have different boiling point, it may have different refractive index, it may have different solubility, it may have different reactivity. So it will have definitely, because the structure has changed, so everything that will change, physical and chemical properties it will change, but molecular formula is same. See first class, that is structural isomers. So where structures are different. So isomers, structural isomers are those isomers in which atoms are completely arranged in a different order with the same molecule. For an example, again we will see the same example of an ethanol and dimethyl ether. Molecular formula is same, that is number of carbon and number of hydrogens they are same. Here also number of hydrogens and number of carbon they are same with an oxygen, only the structure it is different. That is called a structural isomer, where a molecular formula is same but structure it is different. Classified under the structural isomers. We will see one by one what is that. Chain isomers. So in case of an chain isomer, there will be only the difference in the chain. For an example, here is a butane. So butane, it can be written as such way also. There will be 4 carbon and 10 hydrogens, right? Molecular formula, it is different. Molecular formula is same, structural formula is different. And this is isobutane. If we see the number of carbons, 1, 2, 3, 4. There are 4 carbons in both the structures, and number of hydrogens, they are 10. So number of hydrogens, they are 10. So first is N-butane, it is straight chain structure, and second is, that is isobutane. It can be called as an isobutane. Only the chain, attachment chain, you can see that it is having a straight chain, this, and it is branched one. So that is why it is called chain isomer. Only the chain it is different. Now next is positional isomer. In this case, position is different. The carbon skeleton, it remains unchanged. Here you can see that carbon skeleton, it will remain unchanged. Only the important groups, they are moved from the skeleton. For example, say this is one of an example. It is 1 chloropropane, and it can be also written as, for this positional isomer, here it is 2 chloropropane. So this is an example where molecular formula is same. You can see there are number of carbons 3, number of hydrogens 3 plus 5 plus 2, 7 and chlorine 1. Here also carbon number are 3, hydrogens are 7 plus 1 chlorine. So this is called 1-chloropropane and this molecule is called 2-chloropropane. So understand that carbon skeleton is same. Only what is changing? There is change in what? It is change in the substituents. So positional isomer arises when there is a difference in position occupied by the substituent group or the atoms. So chlorine here it is a substituent which has a different position of a substitution. Next is functional isomer. For example, what is a functional isomer? The molecular formula is same but a functional group is odd or functional group is different. For example, propanol and propanone. Number of carbons, you can see that number of carbons, so there are 3 carbons and number of hydrogens they are 6 and number of oxygen it is 1. Here also number of carbons they are 3, number of hydrogens they are 6 and number of oxygen it is 1. Now this structure it is of an propanol, that is an aldehyde. You can see it is aldehyde and next structure it is of an propanol. See it is here it is an ketone. So in this kind of an isomerism, functional group changes. Molecular formula is same but only functional group it is different. So that kind of an isomers they are called functional group isomerism. Further type it is metamers. In case of an metamers, the molecular formula represent 2 or more compounds. It differ in the nature of alkyl group attached to the same functional group. For an example, diethyl ether and methyl propyl ether. From example we can understand it. So this is the compound CH2CH2 di. It is diethyl. So I have written and in between it is having a ether CH2CH3. So it becomes now diethyl ether. You can see that in this molecule the functional group it is in the middle and in the next molecule methyl propyl ether. I will write here methyl. So here it is ether. I will link with an ether and next it is propyl. The functional group or the attachment of an alkyl group to the functional group it is different. So nature it will be different, functional group will be similar in this case. Functional group it is similar, that is ether, but only the attachment of an alkyl group it is different. Both are having the same molecular formula, number of carbon they are 3 and number of hydrogen atom they are 10 and oxygen it is 1. So here also it is same that number of carbons they are 4, number of hydrogens they are 10 and oxygen is 1. Molecular formula is same but there is a different attachment of an alkyl group to the functional group. These are called metamers. Now the last from this structural isomer it is tautomers. In case of an tautomers we can understand with the help of an example. See here molecular formula is same but only the structure it is different. You can see that this molecule it is in a keto form. Here we are having a functional group that is ketone and here the functional group that is an alcohol. So what has changed? The pi bond it is been breaking and it is transferring the electron on an oxygen and oxygen it is giving the electron towards the hydrogen. And at the same time the hydrogen it gives the electron towards the carbon and it forms a carbon-carbon double bond. As we have seen that the pi bond it is breaking and it is giving the electron towards the hydrogen for a new bond formation and here the group it is changing. So it is interconvertible. So this kind of an phenomena where there is only a single compound, there cannot be a two compound and it exhibits in an equilibrium. It exhibits in a dynamic equilibrium, and these structures are interconvertible. But the more stable structure at the room temperature we can see, that is keto form. It is almost 99.9%, and enol form it is below 1%. It is very less. So here keto form and enol form that exhibit in the tautomers, molecule is same, but only in the dynamic equilibrium the molecule will have a little bit change from keto to enol. So this was about the structural isomers. Now the next class, that is stereoisomers. The molecules will have a same molecular formula, structural formula is also same, but different spatial arrangement, or the arrangement of an atom in the space it is different. For an example, we will see cis and trans isomers. See here it is an example carbon-carbon double bond. Here I will take an example methyl, and here we will see an hydrogen, again a double bond. See this kind of an isomer, it is called cis isomer. I will write one more example of an trans isomer. If we give the priority to this molecule, so this will have the first priority and this will have a second priority. Here it is having a first priority and here it will have a second priority. You can see that both the first position around the carbon-carbon double bond, it is same. This example it is of an 2-butene. Why 2-butene? Because number of carbon 1, 2, 3 and 4. There are 4 carbons, and it is having a double bond between carbon number 2 and carbon number 3. So it will be example of an 2-butene. But it is cis 2-butene. It is called cis 2-butene. And this one, you can see the priority group 1 and 2. They are opposite to each other. Here we can see that the priority group here it is 1 and here it is 2 around the carbon-carbon double bond. So this is an example of a trans isomer. So it can be called as an trans 2-butene. It is trans 2-butene. Now understand the concept. Molecular formula is same, right? It is having a same molecular formula because it is 2-butene. Structural formula is also same, but only what there is a different arrangement of atom in the space. What is the difference? That this carbon-carbon around the carbon-carbon double bond, CS3 here it is on the upside and here CS3 it is on the downside. Only that kind of an arrangement, or we can see the connectivity, it is different. Such type of an isomers, they are called stereoisomers. Stereoisomers are been classified into geometrical isomer, where geometry it changes, and already we have seen an example of an trans and cis about it. Next is optical isomers. So it can be classified as enantiomer, diastereomer and mesocompound. Out of that we will take only enantiomer and diastereomer restricted to the syllabus. So geometrical isomers are the isomer where the geometry will change, right? It is a type of stereoisomer where the compounds with the same molecular formula, but the connectivity differs around the double bond, carbon-carbon double bond. So for an example, we have already seen this one. CS3, here I will write CS3 carbon-carbon double bond, and this is the example of an cis 2-butene. Here the similar groups are on the same side of a double bond. Methyl group it is on the same side, or we can say the same priority groups are on the same side of a double bond. Here also hydrogen it is below, and in case of a trans isomer, similar groups are on opposite side of a double bond. For example, say this one CS3, here I will write CS3, here I will write CS3, and here it is hydrogen. You can see that priority groups. So this will have the first priority, this will have a second priority, it will have first priority, here it will have a second priority. Now trans 2-butene, similar groups or the priority groups are on the opposite side. Here it is having one first priority group on the up hand side and second group on the carbon-carbon double bond. It is on the upside, and more priority group it is on the downside. So this was about a geometrical isomer. That connectivity it is differ around the carbon-carbon double bond. Now what are optical isomers? Next class of an stereoisomer, that is optical isomer. It is a type of stereoisomer in which isomers have the same molecular formula. Connectivity is same but differ in the spatial arrangement of an atom such they can affect the rotation of plane polarized light. For example, so this is an example of an lactic acid. These are called enantiomers. Actually, it is a mirror image of each other. These two molecules, they are different. They are differing in the sense of you can see that this is a mirror image. Compound A is a mirror image of an compound B. So it can rotate the plane of polarized. So it will rotate the plane of polarized in this way, right? And this compound will rotate a plane of polarized in this way. So it is clockwise, it means it is R, and it is anti-clockwise, it is L. Or we can also call it is a D isomer and it is an L isomer. Or it is called R or S. It was R or S. So either they can be called as a L isomer or D isomer because the sugars they are been named with an D and L isomer. So we can correctly write it as an only D and L isomer. It means it is a dextrorotatory which can rotate the light from in the right hand side, and the leorotatory means which can rotate the plane of polarized light towards the left hand side. You can see that again we will see that the molecular formula is same, connectivity is also same. There is no difference in connectivity, but spatial arrangement it is different, and they affect the rotation of plane polarized light. So the OH it is on the right hand side, and here OH it is on the left hand side. So that is why it is called a different arrangement in the space. Now there are two types of an optical isomer, enantiomers and diastereomers. So enantiomers are the compound, already we have seen that. See, this is an lactic acid. It will have a mirror image. So mirror image it will be similar of the compound. These are called non-superimposable mirror image. These are called non-superimposable mirror image of each other. Such kind of compounds are called enantiomers. So this one is L-lactic acid. Example is L-lactic acid and D-lactic acid. Lactic acid. Now in case of a diastereomer, we can see an example of a 2-bromo-2-butanol. See, this is an example of 3-bromo-2-butanol. If we see, there are 4 carbons. Carbon number 1, 2, 3 and 4. Here at the junction there is a carbon. And this will be the position number 2 and this will be the position number 3. So it is a structure of a 3-bromo-2-butanol. We will name it compound A and compound B. See, this compound A and compound B, they are having the same mirror image. So these are called enantiomers. And now what is a diastereomer actually? So compound C and D, these are having little bit different arrangement of an atom in the space. Here you can see that instead of Br writing over here the Br, we have written the Br on the right hand side. So the Br position here it is on the left hand side. Now C and D, these are again an enantiomers. So this is a pair of enantiomer. A and B and C and D, it is a pair of an enantiomer. Now what is a diastereomer? What the diastereomers, they are not a mirror image of each other. To be a diastereomer, there should be 2 carbons, 2 chiral carbons. So this is called a chiral carbon atom when it is having a different functional group attached to it. 4 different functional group attached to it. Here it is having only one functional group. It will have only one kind of an chiral carbon atom. But in case of a diastereomer, there should be 2 chiral carbon atoms. Now these 2 chiral carbon atoms, they will form 4 kind of stereoisomers. So here diastereomers are what? See, A and C is the diastereomer. It is not a mirror image of each other. You can see it is not a mirror image of each other. A and B, it is mirror image. So that is called enantiomer. A and C will be the diastereomers. Now B and C will be also an diastereomer because mirror image it is different. Again here C and B or B and C can be a diastereomer because mirror image it is different, but the molecular formula is same, molecule is same, connectivity is also same, but only the arrangement of atom in the space it is different. So this can be B and C can be a diastereomer, and B and D can be also a diastereomer. So these are the 4 pairs of diastereomers, and these are the 2 pairs, that is A and B and C and D, they are called enantiomers, which are called non-superimposable mirror image. Now we will see the summary of this session. See, first we have seen what is isomerism. The compounds with the same molecular formula but different in physical chemical properties. So these are called isomerism. Types, we have seen there are 2 types, structural isomers and stereoisomers. Structural isomer have the same molecular formula but different in the structure. Types of structural isomerism: chain isomerism, positional isomerism, functional isomerism, metamerism and tautomerism. So we have seen all the classes with an example. After that, stereoisomer, types of what are the types of a stereoisomer? Geometrical means where the geometry changes, the connectivity is different. There are 2 classes, cis and trans, where trans they are opposite to each other, and cis the similar groups are on the carbon-carbon double bond, they are on the same side. Optical isomer, which can rotate the plane of polarized light, they have been classified as enantiomer, where the mirror images are same but it is non-superimposable structure, and diastereomer, where it is they are not mirror image of each other. So thank you for watching the video. If you have any doubt, you can comment me in the comment box section. Thank you.